Answer problem number 8. In a frustum of a right square pyramid, each side of the lower base is 22 meters and the slant height is 13 meters. Find the volume of the sphere that can be inscribed in the frustum with a minimum volume given that the sphere is tangent to the bases of the frustum. Okay, so let's illustrate the given problem. So we usually draw the entire 3D figure, but in this case, it might be best to just draw the cross-section of the two solid figures, the frustum and the sphere. So the cross-section of the frustum is an isosceles trapezoid. Okay, now let's label some measurements. Okay, so here, the slant height, okay, if you cut through the slant height, this one is 13 meters. And this one here is equivalent to the length of one side of the lower base. So this would be actually 22 meters. Okay. And then the sphere or the cross section of the sphere, that would be a circle, great circle. Okay. And cut through the middle, will be tangent, okay, to the bases of the frustum. Okay, so it is the unknown radius r here. Okay, so our required is to find the volume of the sphere. Okay, so solution. So let's redraw the figure to analyze how should we go about with the problem. Okay, so it says that find the volume of the sphere that can be inscribed in the frustum with a minimum volume given that the sphere is tangent to the bases of the frustum. So this one is tangent to the base. So to have a minimum volume, the sphere should be able to fit inside the length of the upper base. Okay, here we go. Okay, so in order to satisfy the conditions of the problem. Okay, so let's label again the measurements. This one is 13 meters. Okay, so notice the height of the right triangle is, in this case, let's label this one as 2r. Okay, so that's the whole diameter of the sphere there. Okay, now in that case, the length of the upper base 2 is also equivalent to 2r. Okay, so that means that this length here, okay, is equivalent to if this one is half of 22, okay, so this one is 11 meters. This one, of course, is r. Okay, so this should be 11 minus r. Okay, 11 minus r. So in this right triangle, we can solve the r using Pythagorean theorem. So that would be 13 squared is equivalent to 2r quantity squared plus 11 minus r quantity squared. So let's expand. So this is 169 is equivalent to 4r squared plus 121 minus 22r, okay, plus r squared. Okay, so So this is a quadratic equation. So let's move all the terms on one side. So in this case, I will move 169 to the right side. So you have 0 is equivalent to 5r squared. So that's 4r squared plus r squared minus 22r. Okay. Then 121 minus 169 rather is negative 48. Okay. So with a quadratic equation, let's solve it using quadratic formula. So r therefore is equivalent to 22 plus and minus square root of 22 squared minus 4 times 5 times negative 48 all over 2 times 5. Okay, so let's simplify. So down here it's 10, this is 22 plus and minus. Okay, so solve. Alright. Okay, so 22 plus, okay, square root of 22 squared minus 4 times 5 times negative 48. Okay, so this one should give you plus and minus 38 all over 10. Okay, so there are two possible answers. You have R1 is equivalent to 22 plus 38 over 10, or that would be equivalent to okay, so this one is 6. And we have R2, which is equivalent to 22 minus 38 all over 10, or that is equivalent to negative 1.6. Of course, we don't have a negative radius, so we will just be considering this one, the positive answer. Okay, so this is actually the radius of the sphere. So with that, we can solve volume of the sphere is equivalent to 4/3 pi times 6 cubed. Okay, so this will give us 288 pi, or approximately equivalent to 904.78 cubic meters.